Okay, friends, so what we're going to look at now is a way to get the average from the same group of data that we just got the median and the mode from. Now, you can get the average kind of informally. For example, if you take a look at this histogram right here, and you imagine the histogram as a tray of cookies, where each of the bars is a stack of cookies. Imagine holding the tray at a point at which it would balance. That's where the average should be. And that's fine for a conversational look. We'll talk more about that in the next couple of videos. But as far as a computational look at the average, I've taken the data from that histogram and put it into this distribution. It's exactly the same data, 3 to 4 miles, 4 to 5 miles, 5 to 6 miles, all the way down. And then the frequencies, which is how often we see each of those. So there were 2 commutes that were 3 to 4, 1 that was 4 to 5, and so forth. Now I've left a little column here because that column, we're going to have to use the middle of each of these to actually run the average. We spoke about that earlier. So I think that's called a class mark, but I don't remember. You don't have to know that. I'm gonna call that X, because that's generally speaking what the data is called in statistics. So all I'm gonna do is I'm gonna put 3.5 here, 4.5 here, 5.5, and just keep working my way all the way down to the bottom. Explode my chalk. 11.5. Okay. And now we technically don't even need this anymore. Because really, that's what we're going to have to average, is that right there. So, you could actually do this as an old school average if you wanted to. And we're going to talk a minute why you don't want to. But since there are 2 3.5 mile commutes, you could do 3.5 plus 3.5 plus 4.5 plus 5.5 plus 5.5 plus 5.5 plus 5.5 plus 5.5 plus until you get 29 of those. And then you could add 6.5 plus 6.5 plus 6.5 plus 6.5 until you get 250. And you're hopefully realizing that there's no reason you should do this. This is ridiculous to do this. So I think the easiest way to do it is to use the multiplication that we talked about back in Math 105 and even Math 98. So we're going to take each x value. I'm going to make another column here. We're going to take each of these x values, each of the data points, and multiply it by how many times it shows up, or the frequency. So we'll do 3.5 times 2, and that's going to give us 7 miles. 4.5 times 1, and that's 4.5. The rest of these I already did because I knew I couldn't do them in my head. So 5.5 times 29 is 159.5. 1683.5. 202.5. 119. 47.5. 21 and 11.5. So what these numbers here represent are what you would have gotten had you done 3.5 plus 3.5 plus 4.5 plus 5.5 plus 5.5 29 times plus 6.5 that many times. You would get each of these numbers. And if we were going to add all these things up individually, we would get a sum total. So what you have to do now is get the sum total of this. Now, I'm out of space on this part of the board, and it looks like I actually should use that spot of the board over there. So I'm going to write this as, I'm going to use the summation notation we talked about earlier. What is the sum of each of the data points times its frequency? The sum of the data points times its frequency. That little summation notation is going to come in handy. The sum of the data points times the frequency. Well, that's going to be equal to all these numbers added together, and I cheated and wrote that down too. That's 2,256. 2,256. Now, if you think about what that number is, these are all in miles. These don't have units. That's just how many times you see each of these miles. So that means these numbers are all in miles as well. So that's miles. But to do the average, you have to add up all the data and divide by how many data points there are. We just added up all the data's values, and we got 2,256 miles. So for the average, we just have to take that 2,256 miles and divide it by the 340, I believe, 340 commutes that were in that chart. And if you divide 2,256 miles by the 340 commutes, I get an average of 6.6 miles per commute. 6.6 miles per commute. It's a little bit tedious, not gonna lie, a little tiny bit tedious. But that's how you do what's called a weighted average. You've heard the phrase weighted average before. That's exactly how you do it. We did them in Math 105. We did a little bit of it in Math 98. We'll do more of it in here, and we'll bring Excel into it soon enough. That's definitely a handy way of doing it. But that's how you get the average. Yeah, you can see it visually in the graph, right? If you look at that graph, and you think about where the balance point would be, the balance point is most likely at that tallest bar. Now that tallest bar we called 6.5. This is a little bit more, 6.6. And that should make sense because if you look at that graph, there's a few more commutes to the right of that tallest bar than to the left. So the average, you'd have to move your hand over a little tiny bit to catch that balance. Okay? So that's how you do a weighted average. In the next few videos, I want to look at some more data in grouped form, in distribution form, using bar graphs and histograms. And I want to talk about all these measures of center. We talked about percentages, we're going to let that go as far as the next discussion we're going to have, because a percentage is very different than a median or a mode or an average. You might be asking yourself, why do we have so many? And just so you know, there are even more than the three we've talked about in these videos. I want to kind of talk about why we have so many and when maybe you shouldn't use certain ones. Let's get into that next.